Assalamualaikum and hi everyone. My name is Danish Mukrish bin Muhammad Nazmi. My matrix number is 01DDT21F1019. So today, I will explain to you the introduction of minimal spanning tree. So, a minimal spanning tree or minimum weight spanning tree is a subject of the edge of a connected edge-weighted directed graph that connects all the vertices together with the least feasible total edge weight and without any circles. It is a spanning tree with the smallest feasible sum of edge weights. A minimal spanning for us is a union of the smallest spanning trees for its connected components in any edge-weighted undirected graph that not necessarily like it.
Assalamualaikum and hi. My name is Muhammad Dizo Sharil bin Dizwari. My number matrix is 01DDT21F1023 and I from DDT2A 2.0 Technique Apply. Okay, there are two different algorithms for finding the minimum spanning tree, which is MST. First is Prime's algorithm and second is Krackel's algorithm. For this map, we use Krackel algorithm to solve the problem on our map. Before that, may I explain about what is Krackel's algorithm? It is a minimum spanning tree algorithm that takes a graph as input and finds the subset of the edges of that graph which form a tree that includes every vertex has the minimum sum of weights among all the trees that can be formed from the graph. Move on to the next one, which how does Krackel algorithm works? As we know, Krackel algorithm is called a greedy algorithm that finds the local optimum in the hopes of finding a global optimum. This because Krackel's algorithm makes a locally optimal choice, intending to find the global optimal solution. We start from the edges with the lowest weight and keep adding edges until we reach our goal. The steps of implement Krackel algorithm are listed as follows. First, solve all the edges from low weight to high. Second, take the edge with the lowest weight and add it to the spanning tree. If the edges to be added creates a circle, then reject the edge. Third, continue to add the edge until we reach all vertices. And lastly, a minimum spanning tree is created. Next, I'm going to show you example how to solve using Krackel algorithm. First, you will proceed with the arranging all edges in a sorted list by their edge weights. Next, the first edge that you will pick is edge EF, as it has a minimum edge weight that is 2. Next, add edge FD to the spanning tree. After that, add edge BC and edge CF to the spanning tree, as it does not generate any loop. If you add edge BD, this will generate the loop in your tree structure. You will discard this edge. So next, you have to add AB. This edge does not generate any circle, so you need not include it in the MST structure. The final result minimum spanning tree on the last.
Hi, my name is Muhammad Faisal Zainuddin and my matrix number 01DDT21F1144. Now I will explain to you how can we apply the Krackel algorithm into the calculation.
Before we see the solution, how about we take a look about the question first. Okay, so our team has chosen map seed for the question. And the question is, a tourist wish to have a visit to each city as he lands to the country with minimal distance travel. Suggest the best route for him to enjoy his trip. each of the group will be given a map. So this is our team solution. So as you can see, there are 30 vertices and 29 edges. And to solving this question, our team has using the Kruskal algorithm. So we start with the less weight first, which is weight 1 from keropok warisan losong to pasar cabang 3. The next less weight is weight 2, which is from keropok warisan losong to jiwa kopi and bingsu cabang 3. Next, Pantai Batu Buruk to Kampung Pantai Batu Buruk. TY to Batu Buruk Driving Academy. From Nirwana Hypermarket to Pasar Borong Gong Pau. From Sabahun Hypermarket Sendirian Berhad to JPJ Terengganu. From JPJ Terengganu to Aidin Mall Kuala Terengganu. And the next less weight is 3, which is from SMK Seri Budiman to Haslan Futsal and Indoor Soccer. And then Pasar Borong Gompau to Kampung Malintang. And the next less weight is 4, which is from Kampung Pantai Batu Buruk to TY. From Chizon Cafe to Icon Cafe. And from Nirwana Hypermarket to SMK Seri Mila. Also, with a weight of 4, from Kampung Malintang to Kampung Cengal 8, Keropok Lekor Tokku to Jiwa Kopi and Bingsu cabang 3, from Aidin Mall Kuala Terengganu to Kampung Celong. And then the next less weight we can find is 5, which is from Icon Cafe to Nasi Lemak Womo, Kampung Bukit Kuban Jambu to Kampung Durian Burung Dalam, from Kopi 1 to Kampung Bukit Kubang Jambu. And then the last one for the week 5, which is from Sabahun Hypermarket Sendirian Berhad to Zik Bakery and Cafe. Okay, the next less weight is 6, which is from Batu Buruk Driving School Academy to SMK Seri Budiman. From Nasi Lemak Womo to Kampung Tohpi. From Kampung Tohpi to Pasar Borong Gompau. From Kopi 1 to Lily Merchant Cafe. From Terengganu State Museum to Keropok Lekor Tokku. From Pasar Cabang 3 to Sabahun Hypermarket Sendirian Berhad. And then for the last weight we can find, which consists of weight 7, which is from Haslan Futsal and Indoor Soccer to Masjid Kampung Gong Tok Nasik Kampung Kuala Terengganu, Masjid Kampung Gong Tok Nasik Kuala Terengganu to Icon Cafe, Kampung Cengal 8 to Kampung Bukit Kubang Jambu. And the last one from Lily Merchant Cafe to Keropok Lekor Tokku. And then for the total weight is 127.
Hello everyone, my name is Kivan Raj from DDT2A and my matrix number is 01 DDT 21F1011. Today I'm going to explain about the importance of the minimal spanning tree. Okay, the importance of the minimal spanning tree are used for network designs, which is telephone or cable networks. They are also used to find approximate solutions for complex mathematical problems like the traveling salesman problem. Other diverse applications include cluster analysis. In addition, the advantages are Spanning trees are used to avoid or prevent broadcast storms in spanning tree protocol when used in networks. This is also used in providing redundancy for preventing undesirable loops in the spanning tree or network. Thank you.